Welcome to another episode of My Weird Prompts, an AI-generated podcast featuring the random prompts of Daniel Rosehill as answered by a revolving cast of friendly AI characters. Join us for deep dives into AI, technology, and whatever other random thing Daniel finds fascinating today. Subscribe on Spotify or your favorite podcatcher. Now, today's episode.
This episode was generated using artificial intelligence. Please verify facts.
Hey, Herman and Corn. So I mentioned yesterday that our home server, which is really just my former desktop computer, 10 years of amazing faithful service, finally stopped working, and I'm pretty sure it's the PSU. So ChatGPT, this is what I love about AI. I would have said before the advent of AI that stuff like replacing a PSU was way beyond me. You have to go to a store, find a technician, but it guided me through the entire process of diagnosing the power fault. Learned a little bit about power supply in the process to a computer. Took it out, and I'm waiting on the new PSU to be in stock so I can get all our home assistant back up and running. And I was looking at what PSU to get. Ultimately, I had to buy whatever they had in stock, basically. But there was different times. You had the ones different wattages, gold, bronze, and it made me think that PSUs are the one component of the computer that is without any glamour. No one ever really talks about it. Stuff like the i5, i7 is pretty well known. The RAM, the motherboards. But the PSU is the thing that keeps the whole show on the road. So I didn't do too much research because I really need this, I need to turn on the kitchen lights, be able to turn on the kitchen lights ASAP, and that needs Home Assistant. But I'd be curious to know and learn a little bit about power supply units, what differentiates a basic one from a premium one, and besides the amount of electricity they can deliver, what kind of specs would a savvy consumer be looking for? And final question, for a server as opposed to a desktop where you're going to have that 24/7 expectation of supply, I know there isn't necessarily such thing as server grade PSUs, at least on the consumer home server market. But if you were buying a PSU specifically for an always-on machine, what kind of spec would you be targeting?
So, I was just in the kitchen trying to grab a glass of water, and it turns out the lights are still manual today. It looks like our housemate Daniel is still wrestling with that home server of ours. He sent over a prompt about it, actually. Apparently, 10 years of faithful service finally came to an end, and he is pretty sure it is the power supply unit that gave up the ghost.
Herman Poppleberry, here to confirm that the kitchen lights are indeed offline because our local network is currently in a state of mourning. It is fascinating though, isn't it? We talk about the central processing units, the graphics cards, the fast solid-state drives, but the power supply is like the heart of the entire system. When it stops beating, nothing else matters. It is the ultimate unsung hero of the computing world.
It really is. And Daniel's question is a great one because most people just look at the wattage and the price tag and call it a day. But he wants to know what actually differentiates a basic unit from a premium one. Beyond just delivering power, what are we actually paying for when we go for the high-end stuff? And specifically, since he is looking to replace the one in our home server, what should we be targeting for an always-on machine versus just a standard gaming desktop?
I love this topic because it is where the physics of electricity meets the practicalities of hardware longevity. To start with, the most visible difference is usually the efficiency rating. You have seen those stickers, Corn. 80 plus bronze, silver, gold, platinum, and titanium. But in 2026, a savvy consumer is also looking for the cybernetics ratings. They use a scale called ETA for efficiency and lambda for noise. Most people think that is just about your electricity bill, but it is actually a proxy for quality.
Right, because if a unit is more efficient, it means less energy is being wasted as heat. And heat is the enemy of electronics, especially in a small computer case.
Exactly. If you have a 700-watt power supply that is 80% efficient at full load, you are pulling 875 watts from the wall. That extra 175 watts isn't just disappearing. It is turning into heat inside that little metal box. A premium unit like an 80 plus titanium or a cybernetics ETA diamond might be 94% efficient. That means significantly less heat, which allows the components inside to stay cooler and, crucially, allows the fan to spin slower or even stay off entirely during low loads.
That is a big deal for a home server that is sitting in a closet or a hallway. You don't want it sounding like a jet engine all night. But let's go deeper than the sticker. When you open one of these things up, which I know you have, what are you seeing in a premium unit that justifies a $100 price jump over a budget one?
It usually starts with the capacitors. In a premium unit, you will almost always see high-quality Japanese capacitors rated for 105 degrees Celsius. Budget units often use Chinese or Taiwanese capacitors rated for only 85 degrees. Now, why does that matter? It is about longevity and reliability. Capacitors are essentially little buckets that hold an electrical charge. Over time, the electrolyte inside them can dry out, especially if they are running hot. The Japanese versions are built with much tighter tolerances and better materials, so they can literally last a decade or more under heavy use, whereas the cheaper ones might start bulging or leaking after 3 or 4 years. And lately, we are seeing gallium nitride, or GaN, transistors in the highest end units. They are way more efficient than traditional silicon and allow for much smaller, cooler running power supplies.
So it is literally about the shelf life of the machine. I have also heard you talk about voltage regulation and ripple. Those sound like terms from a physics textbook, but I imagine they have a massive impact on the stability of the system.
They are absolutely critical. Think of it this way. Your wall outlet provides alternating current, but your computer components need very precise direct current. Your motherboard wants exactly 12 volts, 5 volts, and 3.3 volts. A basic power supply might fluctuate. Maybe the 12-volt rail drops to 11.6 volts when you are playing a game, or spikes to 12.4. A premium unit uses a design called DC to DC conversion, where it generates the 12-volt rail first and then derives the smaller voltages from that. This keeps the voltages incredibly stable, usually within 1 or 2% of the target.
And the ripple? Is that like electrical noise?
Precisely. Ripple is the small residual periodic variation of the direct current output. It is like tiny waves on the surface of a pond. If the ripple is high, it puts stress on the voltage regulator modules on your motherboard and your graphics card. It can lead to system crashes, weird blue screens of death, or even long-term damage to your components. A premium unit will have extra filtering stages to keep that ripple very low, often under 20 or 30 millivolts, whereas a cheap unit might be pushing 100 millivolts, which is right at the edge of the safe limit.
That is fascinating because it means a bad power supply isn't just something that might die. It is something that could slowly be killing your other, more expensive components without you even knowing it. It is like feeding a high-performance athlete junk food. They might keep running for a while, but eventually, the internal damage catches up.
That is a perfect analogy. And we should talk about protections too. This is something a savvy consumer should definitely look for. Premium units have a suite of protection circuits with acronyms like OVP, UVP, SCP, and OPP. That is over voltage, under voltage, short circuit, and over power protection. A really good unit will also have OTP, which is over temperature protection. If the fan fails or the unit gets too hot, it will shut itself down safely rather than melting or, in extreme cases, catching fire. Budget units might skip some of these or have poorly implemented versions that don't trigger until it is too late.
I remember seeing some of those horror stories online where a cheap power supply took out the entire motherboard and the graphics card when it went. It is a terrifying prospect. But let's pivot to Daniel's specific situation. He is looking for a replacement for a home server. It is a machine that is on 24 hours a day, 7 days a week. It is mostly idling, doing background tasks, maybe serving some files or running the smart home stuff. How does the criteria change when you are looking at an always-on machine versus a gaming rig?
This is where it gets really interesting, and it is actually a bit counterintuitive. In a gaming rig, you are often worried about peak power. You want to make sure the unit can handle the massive spikes when the graphics card kicks in. But for a home server, the most important metric is often the efficiency at very low loads. See, most power supplies are most efficient at around 50% load. Their efficiency often drops off significantly when the load is below 10%.
And a home server spends most of its life at that low load, right? Just idling.
Exactly. If your server idles at 30 watts, but you bought a 750 watt power supply because you thought more was better, you might only be 60% efficient at that low level. You are wasting power every single second of every single day. For a server, I would actually look for a unit that is ATX 3.1 compliant. That standard actually requires the power supply to maintain a certain level of efficiency even at a 2% load. This is where the 80 plus titanium rating really shines. Unlike the other ratings, titanium requires a specific efficiency level at just 10% load. It is overkill for a desktop, but for a server that is always on, it can actually save you a decent amount of money and heat over several years.
So, for a server, it is not about having the most wattage, it is about having the right wattage and the highest efficiency floor. What about the physical build? I know Daniel was mentioning that he had to take the old one out, and it was a bit of a mess with all the cables.
Oh, that brings up modularity. For a savvy consumer, choosing between non-modular, semi-modular, and fully modular is a big decision. A non-modular unit has all the cables permanently attached. You end up with a huge nest of wires that you don't need, which blocks airflow. In a home server, which might be in a smaller or more cramped case, that is a nightmare. I would always recommend at least a semi-modular or fully modular unit for a server build. It lets you use only the cables you need, which keeps the internals clean and helps with cooling.
And cooling is key for longevity. You also mentioned fan bearings to me once. Is that something we should be looking at for an always-on machine?
Absolutely. Most budget power supplies use sleeve-bearing fans. They are cheap, but the oil inside could dry out, especially if the fan is mounted horizontally. Once that happens, the fan starts grinding and eventually stops. For an always-on machine, you want a fan with a fluid dynamic bearing or a dual ball bearing. Those are rated for much longer lifespans, often upwards of 50,000 or even 100,000 hours. Some premium units also have a 0 RPM mode, where the fan doesn't even spin until the unit hits a certain temperature or power draw. For a server that idles most of the time, that means the fan might not even turn on for weeks at a time, which drastically reduces wear and tear.
That makes a lot of sense. So, if we are summarizing the Savvy Consumer Checklist, we are looking at 80 plus gold, or better, Japanese capacitors, DC to DC conversion, a full suite of protections, and a good fan bearing. But there is one more thing I want to ask about. I have seen people talk about the difference between the brand on the box and the actual manufacturer. Is it true that a lot of these companies don't actually make their own power supplies?
That is one of the biggest secrets in the industry. There are only a handful of actual original equipment manufacturers, or OEMs, that have the factories to build these things. Companies like Seasonic, Superflower, FSP, and Channelwell Technology are some of the big ones. Then you have brands like Corsair, Be Quiet, or MSI who design a specification and have one of those OEMs build it for them. A savvy consumer will often look up who actually manufactured the unit. For example, a high-end Corsair unit might be built by Seasonic or CWT, which gives you a lot of confidence in the internal quality.
It is like knowing which vineyard the grapes came from, even if the label on the wine bottle is from a big distributor.
Exactly. And speaking of confidence, the warranty is a huge tell. If a company offers a 10 or 12-year warranty on a power supply, they are telling you they expect it to last. If they only offer 3 years, they are telling you they don't have much faith in those components. For a home server that you want to set and forget, I wouldn't settle for anything less than a 7 to 10-year warranty. It is essentially an insurance policy for your entire system.
That is a great point. If we think about the future too, I know there is a new standard called ATX 3.1. Does that matter for someone like Daniel, or is that mostly for people with those massive new graphics cards?
For a home server, it is actually quite helpful because of that low load efficiency I mentioned. But for a new desktop build, it is essential. ATX 3.1 was designed to handle the massive power spikes, or transients, that modern graphics cards can demand. These cards can occasionally pull 2 or 3 times the rated power for a fraction of a millisecond. Old power supplies would see that as a short circuit and shut down. The new standard is built to handle those spikes. It also uses the 12V 2x6 connector, which is a revised, safer version of the old 12VHP WR plug. It is designed to ensure a better connection so you don't have to worry about the connector melting under heavy loads.
But for our home server, which doesn't even have a dedicated graphics card, that is probably not necessary for the power spikes. We are more worried about it just staying alive and being efficient at the 30-watt mark.
Right. For Daniel's server, I would be looking for a high-quality, low-wattage unit, maybe a 500 or 550-watt 80-plus platinum or titanium unit from a reputable OEM. It is hard to find high efficiency at low wattages these days because the market wants big numbers, but they do exist, and honestly, it is worth the hunt. It is the difference between a server that lasts another 10 years and one that we are replacing again in 2029.
It is funny how we have spent 20 minutes talking about a metal box that just sits in the corner, but it really is the foundation of everything. If you are enjoying these deep dives into the hardware that keeps our lives running, we would really appreciate it if you could leave us a review on your podcast app or on Spotify. It genuinely helps other people find the show and keeps us motivated to keep digging into these weird prompts that Daniel sends our way.
It really does. And if you have your own questions about hardware or anything else for that matter, you can always get in touch with us through the contact form at myweirdprompts.com. We love hearing from you all.
So, I think we have a plan for the server. We need to find something with a long warranty, high efficiency at low loads, and a fan that won't drive us crazy while we are trying to sleep.
And hopefully something that will get those kitchen lights back on soon. I am getting tired of stumbling around in the dark for my midnight snacks.
Fair enough. Well, this has been My Weird Prompts. I am Corn.
And I am Herman Poppleberry.
Thanks for listening, and we will catch you in the next one.
Until next time.
You know, Herman, I was thinking about the ripple suppression you mentioned. If someone is experiencing weird stutters in their games, could that actually be the power supply? Most people would blame the driver or the RAM.
It absolutely could be. If the voltage is sagging just enough when the GPU hits a certain load, it can cause the clock speeds to fluctuate rapidly, which translates to those microstutters. It is one of those things that is incredibly hard to diagnose without an oscilloscope, which most people don't have lying around. That's why starting with a solid power supply is so important. It eliminates so many potential headaches down the road.
It is the ultimate preventative maintenance. It is like having a good foundation for a house. You don't see it, but if it is bad, the walls start cracking and the doors don't close right.
Exactly. And for a server, it is even more about data integrity. If the power fluctuates while the hard drive is writing data, you could end up with corrupted files. For someone like Daniel, who is running his whole life off that machine, that is a risk you just don't want to take.
Well, I am glad we cleared that up. I think I have learned more about capacitors today than I ever thought I would.
That is the goal. There is always more to learn when you start looking under the hood.
Definitely. All right, let's go see if we can find a unit that fits the bill so we can get that Home Assistant back online.
Lead the way.
Thanks again for listening, everyone. You can find us on Spotify and at myweirdprompts.com. We will see you soon.
Goodbye for now.
This episode was generated using Gemini Flash 3. Text-to-speech engine was Chatterbox Turbo.
Thanks for listening to another episode of My Weird Prompts, an AI-generated podcast featuring Daniel Rosehill's AI prompts as answered by a revolving cast of friendly AI characters including me, Cornelius the Sloth. Subscribe on Spotify or visit myweirdprompts.com.